Good afternoon, class. We are looking at Chapter 1 sequences. Here's 1.6 sequences and difference equations. This is not something brand new. You have seen it before. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2 through a sub n. Here's the first term. Here's the second term. Here's the nth term terms of the sequence. A sub n is the general term, and n is the set of positive integers. Recursive sequence, also known as difference equation. That's a type of sequence where the next term depends on knowing the previous one or previous ones. We write down a sub n plus 1 equals f of a sub n. That's the way we write it. A couple of familiar sequences, arithmetic and geometric sequences. This is from algebra. I hope everybody remembers that. An arithmetic sequence, a sub 1, a sub 1 plus d, a sub 1 plus 2d, and so on and so forth. So basically, we add a difference, also known as a distance between consecutive terms. It's constant and can be defined by, here's how we can define it. There are different ways of defining this. If we want to go recursively, a sub n plus 1 is a sub n plus d, a constant. So if you want the next term, you pick the previous term and add a constant. Explicitly, a sub n is a sub 1 plus n minus 1 times d. Notice we are adding 4. 1 plus 4, 5 plus 4, 9 plus 4. So d is 4. Here, a geometric sequence, we start with a sub 1, then we multiply by r, a sub 1 r, a sub 1 r squared, and this is a general term, a sub 1 r to the power of n minus 1, where each term is r times the previous one, and we can define it as follows. R is a constant, we call it the ratio, versus a difference or distance. Recursively, a sub n plus 1 is r a sub n. In other words, if you want any term, pick a previous one multiplied by 4. Explicitly, in general, a sub n is a sub 1 times r to the power of n minus 1. Notice 1 times 4, 4 times 4, 16 times 4. Therefore, in this case, r equals. The ratio is a constant. We had discussed this before when we did the summary, so I'm going to refresh your memory. A sequence is a list of numbers written in a specific order, measurements collected at discrete time points and quantities that undergo periodic changes such as annual plant or insect populations are studied using the concepts of sequences, the data. And difference equation, the description of the mechanism of change, the description, the equation in essence. And again, refreshing your memory, this is not brand new. A sequence, a real valued function, f whose domain is a natural numbers. One might say natural numbers or positive integers, 1, 2, 3 to infinity. So the first term is a sub 1, second one is sub 2, the third one is a sub n. Now we start with examples, and as far as the examples are concerned, you're going to write solutions. You don't have to write the questions again. All of this available to you, everybody. Let's start with the easiest example. A sub n is n. So basically choose n to be 1 because we want the first 5 terms. If n is 1, a sub 1 is 1. Let's choose n to be 2. A sub 2 is 2. So that means this number and this number must be identical. That's the concept. So a sub 3 is 3. A sub 4 is 4, a sub 5 is 5, and we are done. Extremely simple. Well, we're going to do the same thing here. We're going to replace the n with 1. We get sine of 1 times power over 2 of power over 2. If I put 2, and I want to show you, if I put 2, everybody, I get b sub 2 is sine of 2 pi over 2. What is 2 pi over 2? Pi. So we can write the next one and the next one and the next one. Please notice this one. So this is 1 pi over 2. This is 2 pi over 2 or pi. This is 3 pi over 2. This is 4 pi over 2. 4 pi over 2 or 2 pi. This is 5 pi over 2. What are the values? Well, anybody remembers sine of pi over 2 from basic trigonometry? All right. I'm going to go over that quickly so you remember. By the way, just make sure your name appears just the way it appears on the road sheet. So if your full name is not there, click on the right side and change it to a full. I'm going to remind you of what you're going to see, of course, in the exam, in the algebra review also. Here's a circle centered at 0, 0, x squared plus y squared equals r squared. And when it's centered at h and k, x minus h squared plus y minus k squared equals r squared. When the radius is 1, this becomes 1 squared over 1. We call it a unit circle. So when it's a unit circle, this is located at 1, 0, 0, 1, minus 1, 0, 0, negative. And so as far as the angle is concerned, the angle is that it makes with the positive side of the x. So this angle would be 0, this would be 90 degrees, this would be 180, this would be 270, and so forth. So, for example, right here, this angle is 0, tangent is 0, sine is 0, cosine is 1. I want to make sure we understand, because this, remember, this location is 1, 0, right, class? So sine of 0 again, this has coordinates 1, 0. Sine of 0 is 0. Cosine of 0 is 1. Why is that? Because every point, like this point, has coordinates x comma y for cosine t comma sine. So the x coordinate is cosine, the y coordinate is sine. Therefore, this one, cosine of this angle, which is 0, is 1, sine is 0. Over here, what about this one? Here's the angle, everybody. 90-degree angle. So for this one, cosine of pi over 2 or 90 degrees is 0, but sine of pi over 2 is 1. For this one, cosine of pi, because this is pi or 180 degrees, is negative 1. Sine of pi is 0. This angle is 270 degrees. So cosine of 270 degrees or 3 pi over 2 is 0, but sine of 270 or degrees or 3 pi over 2 is negative 1. I hope this will help you remember, because we have those points, right? Those common arcs and their trigonometric values. All right. All right, let me erase the mess. And those are the answers. Sine of pi over 2 is 1. Sine of pi is 0. Negative 1 is 0. Sine of 2 pi is 1. And sine of 5 pi over sine of 2 pi is 0, and sine of 5 pi over 2 is 1. All right, here's the next one. And I hope everybody can see, basically replace the n with 1. If you replace the n with 1, let me write that. If I replace the n with 1, I put C1 is 1 over 1 plus 1, which makes it 1/2. C2, 2, replace the n with 2, right? 2/3, and the rest of it. Very straightforward. D sub n is the digit in the nth decimal place of pi. First, let me remind you what is pi. Pi is not equal to 3.14. It is approximated by that. Pi is 3.14159, and it continues indefinitely. So the very first decimal is 1, everybody. So D sub 1 is 1. The second one is 4. D sub 2 is 2. The third one is 1. D sub 3 is 1. D sub 4, D sub 5, D sub 6, and so forth, but we want only 5 of it. So I hope everybody understands the question and how we arrive at those answers. 1, 4, 1, 5, 9. Again, pretty straightforward. All right, we want to come up with the first 5 terms where a sub n is 2 to the power of n minus 4. So let's see how we do that. Let's start with the first one, everybody. Again, you have the questions. We are going to go over the answer. So if I replace this 1 with 1, I get 2 to the power of 1, which is 2 minus 4, making it negative 2. Can anybody tell me what's a sub 2? Anyone?
2.
One more time.
2.
A sub 2. If I replace the n with 2, I get a sub
2.
2 squared is 4 minus 4 is 0, isn't it?
Oh.
So when we replace the n with 2, we get a sub 2, and 2 squared is 4 minus 4. How about the third one? Anybody? What would be the third one? Replace the n with 3. What do you get?
4.
Beautiful. If I put 3 here, I get 2 cubed, which is 8 minus 4. And so if I show work for 2 of them, means I know the rest of them. And by the way, I'm going to leave it for everybody to figure those 3. I explained that. Just make sure you can come up with a sub 4 as well as a sub 5. Let's go the reverse process, finding the general form, the formula. And some of them may be pretty involved, but you may notice that this one, you want to concentrate on the first one only. Notice what happens. You go from 5 to 8, and then 8 to 11, 14, 17. In all cases, what are we adding? Number 3. So that makes it an arithmetic sequence where the D is 3. So again, notice we are adding 3 here. Okay. And now we remember the general formula. A sub n is a sub 1 plus d times n minus 1. And all we have to do, replace the first term with 5, replace the d with 3, and simplify. When we do that, this becomes 5, this becomes 3n, this becomes minus 3. And 5 and minus 3, they can be added. So we get 3n plus 2. If we look at the second case, what do we notice? we notice if we multiply this by negative 1/3 with this one, we get negative 1/3. If we multiply it by negative 1/3 again, we get this one, 1/9. So divide this one by this one by this one by this. You have to really try a few of them. And you notice we have a constant ratio of negative 1/3. And we go with the general format of a sub n equals a sub 1 r to the power of n minus 1 because it's a geometric sequence. GS, short for a geometric sequence. So we are going to use that again. Just want to make sure that we understand this is geometric. And so we write it as follows. We can write a sub 1 is 1, and then r is negative 1/3 to the power of n minus 1. But what happens in the case of a sequence is we don't like to have a negative sign, so they separate the negative sign. They write it as negative 1 to the power of n minus 1, 1/3 to the power of n minus 1. What I want to explain to you about this negative 1, this makes this, as you can see, an alternating sign, alternating sequence. It goes from positive to negative, sometimes from negative to positive. If that is the case, you will always need negative 1 to some power. What I want you to notice is this. For alternating sign, start with negative 1 to the power of n or negative 1 to the power of n minus 1. If I put n and I start with number 1, negative 1 to the power of 1 is negative 1. So if the first one is negative, has a negative sign, this is what we use. If the first one has a positive sign, this one. In some text, they may use n plus 1. It gives you the same result because when n is 1, 1 minus 1 is 0, minus 1 to the power of 0 makes it positive. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one. We've already discussed that, known as a difference equation, and it may not always be possible to determine the general term of a sequence algebraically. Sometimes it's pretty difficult. So a difference equation or recursive sequence is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real values function. A solution is a sequence a sub 1, a sub 2, all the way to a sub n, which satisfies the given difference equation. So that's a definition. One of those sequences is called Fibonacci sequence. I hope you remember that. That starts with number 1, and the next one is number 1, and then we start adding them. So we write f sub n is the previous one and the previous one, where n is larger than or equal to 3. In other words, first, we have number 1. There's nothing to add to it. We write this 2. Now, if we add this 2, we get 2. Add this 2, we get 3. 2 and 3 is 5. 3 and 5 is 8. 5 and 8 is 13. 18 and 13. 8 and 13 is 21. 21 and 13, as an example, over here, we have 34. Okay. Fibonacci sequence and examples. In nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. So you have 1, the next year you have 1, and the next year you have 2, and then we have 3, and then the next year we have a lot more, 5 and 8, and so forth. So it happens in nature. All right, class? We want to find the first 6 terms, and as long as we can show 1 or 2, that means we can do all of them. So let's start with this simple one. The first one is given. I want to make sure we understand the meaning of that. If you want any term, a sub n plus 1, what is a sub n? The one before that, divided by n. So if I want according to this, if I want a sub 2, then I need a sub 1 divided by 1. which is 6 divided by 1, which is 6. You follow what I'm saying? That's that. Let me just erase mine. Okay. So, for example, a sub 3. Can anybody tell me what would a sub 3 be? The next step? According to this formula, a sub 3, if I want this to be 3, this must be 2. It's a sub 2 divided by 2, which means 6 divided by 2, which means 3. I'm going to do one more. If I want the fourth one, according to this formula class, according to this formula, if I want a sub 4, so this number is 4, right? Then I want a sub 3 divided by 3. So 3 divided by 3 is 1. I'm going to leave it for you to figure out the rest of them. You have to practice with those. Okay, so we did the first few. Okay, we did all the way to here. All you have to do, convince yourself the other two are 1/4 and 1/2. Now, we have the first term, we have the second term, and any term we want depends on the previous two terms in the following manner. A sub n plus 2 is a sub n plus 1. That means if I want the next term, I need the previous one, plus 2 times the one before that. So I have a sub 1 and a sub 2. I'm going to write a sub 3. So if I change this, take a look, see how easy it is. If I want the third one, that means I want this one to be 3. N plus 2 is 3, that means n is 1. So replace this n with 1. This makes it a sub 2. And replace this one with 1. So we want a sub 2 plus 2a sub 1. A sub 2 is 2. 2 times 1 is 2. They add up to 4. Okay. Now use this formula to write a sub 4. A sub 4 is a sub 3 plus 2a sub 2. Please understand the concept here. If you want any term, pick the previous one. So I want the fourth one, I pick the previous one. And then the one before that, multiplied by 2 and add. So I want a sub 4. What is a sub 3? A sub 3, we have it as 4 plus 2 times a sub 2 as 2. 2 times 2 is 4. And this 4 adds up to 8. Is everybody clear on that? And again, a sub 5 is a sub 4 plus 2a sub 3. So if you want a sub 5, the previous one, and then 2 times the one before that, according to this formula. So this one is 8, 2 times a sub 3, which is 4, and they add up to 32. 16 and 32. And so it's a good practice that you do this one. In fact, find the next one and then 16. This is 16. And the next one is 32. How about this one? If you want a term, 2 times the one before that minus 4. Okay, so as an example, I have the first one. Now I want a sub 2. So if I want a sub 2, that means n plus 1 is 2, right? That means n is 1. So I want 2a sub 1 minus 4. Please replace the n plus 1 again. I want to make sure that you understand. If I replace this with 2, n becomes 1. That's where you put it. And 2 times 3 is 6 minus 4 is 2. Let's do one more. Just make sure we understand that. If I want the next one, if I want to be 3, I want this to be 3, a sub 3, then I want 2a sub 2 minus 4. And a sub 2 is 2. 2 times 2, 4 minus 4 gives us 0. So as long as you can show work for 2 of them, you can figure out the rest of them. So again, we did a few of them. Please do the rest of them on your own, making sure you can come up with the answer. I hope it's pretty straightforward. Suppose C sub T is the concentration of a drug in a bloodstream at time A. A is the inflow. It's the concentration of the drug that is administered at each time step. And K is the fraction of the drug metabolized or absorbed in a time step. What is the recursion that models the dynamics of drug concentration? So we want to discuss this. First, n sub t plus 1 is n sub t, whatever we had there, plus what we add. What do we add? Some inflow minus whatever it takes out. What do we add? We call it outflow. Now we're going to figure all of those. Since we are dealing with C sub t, this is a general form, C sub t concentration, we're going to change this to C sub t plus 1. So this is C sub t plus inflow, we called it A. And what about the outflow? Now, you want to make sure you follow that. As far as the outflow, it says K is the fraction. For example, K is 10%, 20%, 50%, 70%, or 1/2 or 2/3, some sort of a fraction or percentage of the drug that is gone, that is absorbed. So for example, if 70% is gone, 30% is left. That's why this one, so this one is 8. This one we're going to say minus K times C sub T. Pay attention to this again one more time. We're going to change the N to C because of the concentration. So N sub T becomes C sub T. What comes in? A amount. What goes out? This percentage. So if we have this much, a percentage of that, a fraction of that would be whatever this number is times that. I hope everybody is following that. And so if I combine this one and this one, I get C sub T times 1 minus K. Now, if the initial concentration C sub 0 is 120 micrograms per milliliters, and A is 80 micrograms per milliliters, and K is 1/2, plot some points on the graph and come up with the answer. So let's see how we do that actually. So first and foremost, we are going to plug in by writing the information. In this case, C sub 0 is given, A is given, and K is 1/2. So into this formula, okay, we're going to replace the K with 1/2 and A with 80. That's why whenever you do word problems, writing the given is important. Okay, everybody. And I hope you realize 1 minus 1/2 is 1/2. So half of C sub T plus 80. So if we were to write a few of them, for example, now that we have the general form, let's write C sub 1. C sub 1 is half of C sub 0 plus 80. C sub 1 is half of C sub 0 plus 80. And as you know, C sub 0, we wrote it here or here, C sub 0 is 120. So half of 120, which is 60, and 80 gives us 1/3. If I want C sub 2 is half of C sub 1 plus 180. So half of 140 is 70, and 80, 150. Can anybody tell me the amount of C sub 3 with this recursion formula? What would be the amount of, we got C sub 1, we got C sub 2. Can anybody tell me what is C sub 3, the amount of C sub 3? Anybody? C sub 3 is half of this, everybody, which is 75, plus 80, which is 155. So C sub 3 is 155 because it's C sub half of C sub 2 plus 80. Let me write at top of it. So this C sub 3 is 1/2 C sub 2 plus 80. That's the reason. Now, as far as the formula that is mentioned here, if you plot those numbers, looks something like that, and it will taper off, and it uses the limit, and we're going to discuss the limits later on. A over k, 80 over 1/2 is 160. What this means is, if you follow this recursion and add a time step, and by the way, time step may be every 2 hours, every 10 hours, every week, every few hours, whatever it is, the amount of medication that is there, it will never exceed 160. That's the limit that is important to me. Okay. I'm going to look at the last question. There are a couple of versions we want to look at. Could somebody quickly read the question, please? Could somebody read it, please? Anyone? I really appreciate it.
Pacific
which is-
salmon,
Go ahead, Diego.
Pacific
Go ahead.
salmon populations have discrete breeding cycles in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species.
Go ahead.
Suppose that each fish must first survive predation by bears while swimming upstream, and the predation occurs with probability D. After swimming upstream, each fish produces 3 offspring before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamic, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey.
Perfect. We can work on part A, and then we see what happens with the rest of it. Notice what we have here. Okay. First and foremost, so we are looking at the situation where the number of fish we don't know. You can call it X, Y, Z, lowercase n, or n sub t. That's what we have to begin with. When the predation happens, okay, the probability is D. That means 10, for example, let's say these 10%, that means 10% are preyed upon and they're gone, and 90% is left. So after the predation, what is left? 1 minus D times n sub t. So we call it n sub p. Whatever we had here, whatever we had in the previous step, this is the fraction or a percentage or a portion that will be gone. So d times that will be gone, and you can replace this statement with 1 minus d times n sub t. What is the next step? After swimming upstream, each fish produces b offsprings before dying. So basically, they get multiplied by b offsprings, but since they all die, we don't add that one. So there are a couple of ways to write it. One simple way, basically multiply this by b. Each one give us 5 times that. Each one give us 10 offsprings, 10 times that. So whatever this is times b. Now, what I wrote here is this step n sub p. We get it b times n sub p added, and then minus n sub p because they die. Okay? Or simply put, just multiply this one by n sub p. So this one we multiplied by p. And then what happens? We add. How many do we add? M. So that's the first case. Now, what if we change this slightly? Take a look. What if we change this slightly? How? Again, we start with so many x, y, z, or n sub t. So instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. That means now each fish goes up and gives us b offsprings, b times that. Again, you can write this one plus b times that minus itself, or simply multiplied by b because each one gives us 5 times that, 10 times that, or b times that. Now we add m additional, newly hatched fish. So add m. All fish, all of it, will face predation. So 1 minus d times that. Again, because if d is 10%, 90%. 1 minus d is the complementary event. So if d is 10%, that means 90% is left. If d is, let's say, 1/3, that means 1 minus d, 2/3 would be left. And the last part of the question says, okay, so in part A, we got this number, b times 1 minus d n sub t plus n. And in part B, we got 1 minus d times b times n sub t plus n. Which one of the recursions in part A or B predicts the largest increase? Which one gives us more? Well, there are two ways to approach it. One is to look at it with more details to see what happens. One is just subtract one from the other. Okay. If you want to explain that, we may have different explanations from the biology point of view, but I want you to see it from a mathematical point of view. Needless to say, D is a number between 0 and 1. It's always positive. B, the number of offsprings, is also positive. So if we subtract part B from part A and the result is positive, then A is larger. If the result is negative, then B is larger. So part A minus part B. You have two choices. You can, simplify it by distributing or not. If you just write this part, again, this is a simple math. You can do it as you wish. So write this one plus n, then minus this times b and times n sub t, and then 1 minus d times m. All of it, this one has a negative sign. And so 1 times m with a negative sign, and then minus d, that means plus d times m. So we end up with this. So I hope you see these two are the same. And so what happens, again, just distribute and you can observe. If I drop these two, and if I drop these two, the only thing left is md, and md is positive because m is positive, so is d. And it makes sense because all the additional fish survive in part A, whereas in part B, all fish face predation.